Hi everyone. In this lesson, we're going to be looking at data types and how you can pass more than one type of data type to a common function block, how we detect that, and how we run different code based on different types that are passed to our function block. So what you can see on the screen at the moment is an example of how it's set up in a very basic sense. So we have a data type A and a data type B. They contain completely different information. Some of it's common, some of it isn't, and they are passed to the same interface input on our function block. When they're passed to that interface, it goes through this following process on the right hand side here, which is the data type A? If it's not, then is the data type B? If it's not, then it's the incorrect data, and the function block stops there. If it is A, then we process code relating to structure A. If it's B, we process code relating to structure B, and then both of them end up doing common code, things that reside in both A and B, before finishing the function block. And this approach is extremely useful for function blocks that have large sets of common information, but may need to do something slightly different because we're using a slightly different structure. So, for example, a flow meter and any other sort of analog signal have lots and lots in common. They're 4 to 20 milliamp signals, for example. They need to go through high alarms, low alarms, but a flow meter may also have a totalizer. That totalization part of the structure could be handled in this fashion, where A is a normal analog, B is a flow meter. We do everything that the flow meter would usually do in the sort of B section, so process code relating to B, and then we go on and do the common code to A as well, which is the analog side, like the management side of the analog. So let's take a look at how this looks in a actual PLC system. I will say that the way Codesys manages this is not the nicest. Siemens, for example, using variants, handles this much better. But we're working with Codesys, so I'll walk you through what we're doing and how it's working. So this is our PLC program, our main executable task. And what we're using here is something called var info, which is going off and getting the information about a variable. So we can see here analog info is a system var info, and if I open this, there's quite a lot of information in here, but it's basically the general information about this variable, which is gvl.analog. Now, on previous lessons, we've used DUT analog, and I think we've used DUT level as well, so I'm not going to go into too much detail about what these are. They are just standard structures that we want to pass into our function block. So if we quickly jump back to our image that we saw at the beginning of the lesson, the problem with this example is that we can only pass the any variable type as an input, which is a problem for us because we want to be able to update information in this structure, but we are unable to set up any variable as a input and output. So what we've done here is we have a data which is an in-out, and if we have a look at the data type of this, it's a system var info. Now earlier I said that this was the address, so this is the address, or a pointer if you like, of where this information is residing in our PLC. So this value here, which Codesys sorts it out by itself, this value here points to this GVL global variable list here and the information inside. So this analog value inside, what we're seeing here is actually the level because it's the last one that's being scanned, and they're both using analog info, but it points to where this information actually resides. So if we go inside the analog manager, it's written in structured text. The reason for that is that the var info is only available in structured text in Codesys. Some other PLCs might have systems that are very similar, like Siemens, for example, has the element type or type element, or it's a way of checking what the type is, which can be used in ladder or structured text or function block diagram, I believe. But unfortunately, in Codesys, it is structured text only. So what I've got at the top here is just, these are just pulling in some information so we can have a look at what it looks like inside a block. So this anyvar is our data, and then we have references to a analog data structure and a level data structure. So these are the analog data that's in our GVL and the level. So DUT level, DUT analog, and in here analog data, level data, which are of those types. So level data, DUT level, analog data, DUT analog. And these are set up as temporary variables inside the, or rather normal variables inside the function block, so we can pass some information to them and have a look at what they look like. Have a look at what they look like inside on this analog var info and level var info. So if we have a look here, we'll see that now we have a byte address of 0. That's because it's now local to the function block. Again, if I go and have a look at level, we have a byte address of 0, which means that we wouldn't be able to use these internal variable infos as pointers to work with on this byte address, because it doesn't have a byte address. It's got no fixed location because it's a symbolic reference to wherever Codesys is sorting out where that information is going. Whereas if we look at anyvar here, you'll see that this now has 0 as well. And that's because we're now looking at the interface bit. So we're no longer looking at our data. Our data has been passed as an input, which is a copy. So there's no reference anymore. We've now copied the information through the interface. So you'll see that although this says it's a user-defined type, I just expand this, the type name is no longer our DUT analog. It's now system var info. So we've lost that information. Now, that could be a problem if we were passing our data as our normal structure, but we're not. We're passing our data as a var info. So if we have a look at data coming in, you'll see that we've retained that pointer, and we've retained the fact that it's a DUT analog. So if we come down the logic here, this is already set to true because we're looking at it at the end of the scan, and I have some logic down here that says if DUT analog, if data type name, which is DUT analog, equals analog var info, which is this analog var info here, type name, which is this here, so they're the same. Then we go on and we do a memory copy. So if I go back to my image here where we say process code relating to structure A, what I'm doing now is pointing to the actual data as opposed to a copy. So this is my pass by reference, but I'm having to set it up manually because we are having to pass this information in as an input. So what I have here is my destination. So P destination, this is the target area that we're going to move information to. And then I have my pointer source, which is my data byte address. So remember, we're passing in var info. So the byte address is this L word here, which is a pointer to our GVL analog data that we're passing in. And then what I have here is analog var info again. So again, looking at the info, and for some reason, Codesys decided that they would pass or tell us the size of the object in bits, which seems a bit strange because almost every other PLC I've ever worked with would tell us in bytes, but it tells us in bits. So dividing it by 8 gets us the length of our structure in bytes, because the count needs number of bytes to be copied. And then we set our analog flag to true. So at this point here, what we've done here is we've successfully detected that we're passing a type of DUT analog. Because we passed the analog var info, which contained a pointer address to the global data, we have then moved that global data or copied that global data from that area into a temporary structure inside our function block, which is always there, set up as the same size or of the same type as analog data. Which brings me on to a point that if you had, say, 100 structures that you were trying to be sort of polymorphic with in this approach, you could run into some issues where your function blocks are massive because you're having to designate that space. So you can use temporary variables. The problem is with temporary variables is they either introduce jitter to the PLC when you're online monitoring, or in Codesys' case, you can't monitor them very easily because they're not retained between scans, so you end up with question marks and you can't see the values. You can put flow monitoring mode on, which can help, but even flow monitoring doesn't show them in all cases. So you've got to be a bit careful with how big this is getting, and sort of make sure you structure stuff in a way that really you're only going to do this if it's something that you do often. You have this function block and you pass these different data types to it in a way that is worth doing this. Otherwise, you're going to cause yourself some issues, and your code will be massive as well. Okay, so that being said, we'll skip over the level type for now because we'll come and have a look at the level type after. So these have all got default values in, but what we're doing here is we're saying if we are being passed an analog value, then our analog scale block here is using the analog data, scaling data raw min, very similar to what we've seen in previous lessons. However, if we're using level, then you'll see that we're now looking at a different structure. So we're now looking at level data dot analog, because level data has the analog structure embedded or nested within it. So this is the sort of process stuff that's A that we saw in the image, which is our analog scale or analog data, and then process stuff that's relative to B, which is our level data. We're having to process them separately because the access to that information is in a slightly different way. And then what we have down here is if we are running with a level as opposed to a standard analog, then we can perform this bit of code as well, which is working out the percent and the volume of the tank or whatever it is the level is monitoring. And then, so that's sort of like the code stuff done. An example of being able to pass A, which is the analog, and doing this stuff here. And if we're passing B, we'd still do the same function, although we'd access the information a different way. And then we'd go on to do an additional step that the analog data doesn't need to be, it doesn't even exist in the analog data. So this is the sort of extension for the level structure data, which we'll have a look at in a second. And then this is the write back area. So very similar to, this is the write back area here. So very similar to what we did at the top end. So here where we are bringing information in via our pointer, what you'll see down here is we're doing exactly the same, but we're saying our source now is our temporary analog data. This ADR here, I should have explained this earlier. This ADR here is Codesys sort of get me a reference or a pointer to this information. So this this sysmem copy here needs a pointer so it can point to the byte address. ADR is a function that gives us that information. It's not represented at all in structured text or in ladder. You can't see what that value is, but it's performing the same thing essentially, which is getting a pointer to where this information is. So we're going to pull that information out as our source, and we're going to put it back to where this byte address points, which is back in our level or analog global variable list. So to demonstrate that, I just make this a little bit smaller and I pull up the GVL, which is already open. Let's snap it to the side here. So I believe we are in the analog manager instance. Yeah, so we're looking at analog. So if I go ahead and give it some scaling data, so let's give it 4,000 as min, 20,000 as max, 0 to 10, and I'll give it a raw value of 12. So we should see 5 on the scale value, which we do. Now the only way we can see scaled information here is if this was writing back, because we're not interacting directly with this data. Nowhere in PLC program are we pulling in gvl.analog. We're pulling in analog info. So the only way for this to be working is for this byte address pointer system to be both reading the information, which we can see it's doing here, and then the output for analog data being written into the temporary analog data here. And when we get down to this point here where we check again, IUDUT analog, it then writes it back through this system memory copy event. So previously we've spoken about the efficiency benefits of using in-out. Some of that is still preserved with this method because this system mem copy, we're still using pointers in order to move this information around, but essentially it's still being copied. We're still storing this in a temporary variable. We're still having to copy the interface on the for the var info. So this is a much less efficient approach to the standard in-out structured method that we've seen previously. However, I would say that the benefits of being able to load two or more structures that are similar and manage them in one location outweighs that in my view, depending on if it's done correctly and if it warrants it being done that way. So this is a very crude example. One that's worth mentioning is if you were to take the example of managing variable speed drives. Now there are many different manufacturers that have different hardware, and there are also different control methods that we may want to implement, such as PID control or just direct control, like I need you to go to this speed, go to this speed straight away. There is no PID, it's just I've asked you to go to 50%, I need you to go to 50%. There's no process values or anything to look at. And then we've got things like Danfoss, Siemens, Parker, all these different manufacturers. You can use this approach to have a standard function block that interacts with our SCADA systems and our sort of general logic around VSD drives, irrespective of the hardware that we're using, because we detect the hardware type and we control it however it is that piece of hardware needs to be controlled. And then we do exactly the same with the control method, where we detect the control method type, so whether it's a PID through a PID structure or whether it's through a external request, which would just be a structure with a single variable in, but we can still detect that structure type and say, okay, it's being controlled this way. And suddenly you have a function block that is capable of controlling any drive that you use in your system, irrespective of its hardware or the control methods that are required later on. With that being said, let's quickly switch over to the level. So we were looking at analog manager instance. Now let's have a look at level manager instance. And I won't put variables in or anything, but just to show you that we are now here. So level equals true. We're still getting a byte address, and now what's happening is, although this information is here in analog, we're not picking any of that up because we're looking at level now. So I will just quickly stick in a raw value of 10,000. And you see we're now looking at 10,000. And this, if level true, we're now looking at calculating percent, which is obviously giving us a rubbish value because we've got no scaling, and a volume. And then we have our output layer here. So this is an awful lot of information to take in if you've never thought of sort of programming this way. But sort of watch this tutorial again, this lesson again, pick apart the sort of key information I'm saying, and download this as a resource and step through it. I promise it's not as convoluted and crazy as I sort of make it sound sometimes, but it's relatively straightforward once you get your head around what's happening. And like I said, it can unlock the door to some potential issues that people have come across before. I've seen countless projects that have 20 different function blocks for managing assets that are so similar. It might just be one or two things in the data that are different, and we've got new structures for that, we've got new function blocks for that. Suddenly your sort of libraries become difficult to manage because there's so many different variations of stuff that's the same, even to the point where people literally run out of names for them. So yeah, download it, have a go, and if you're stuck or you don't understand something, definitely ask me questions. I feel I haven't done this one justice really, so definitely ask me a question if you're unsure about anything.